For this worksheet, my plan is to do 2 reactions per video. Otherwise, I think it's probably going to be really long. And I do still want you to try to do the reactions on your own, and then watch the video and see how you did. And also keep in mind that there's more than one way to skin a cat. So the way that I do this reaction might be different from the way that you chose to do it. As long as you end up doing the right thing, that's really all that matters. And I want to walk through kind of what I'm thinking and what I'm looking at as I'm solving these problems. So for the first one, what I'm looking at is I can see, I'm going to kind of like trace the part of the molecule. This is what I've started with, and I'm assuming that those 6 carbons are ending up over here in the product, which means that I am adding this stuff right here to the molecule. And so what I'm going to look at is, what am I adding? Like, what functional group am I adding, and how do I get that functional group on the molecule? So this functional group right here that I'm adding is the acetal functional group. It's the oxygen, carbon, oxygen, single bonded together. And we know how to form an acetal. It is formed from carbonyl carbon reacting with a couple of alcohols. So knowing that I need to do this acetal reaction, my strategy is to find the acetal group. So there it is. The carbon in between the 2 oxygens is the carbonyl carbon of my reactant. I am going to pick one of the oxygens of the acetal to be the carbon-oxygen double bond. I'm going to break off the other oxygen and break the other bond as well. So that means that my reactant, don't forget stereochemistry, I had a piece that looked like that. I'm going to put my aldehyde on the arrow. So I had a piece that looked like this guy. And to this right here, this reactant right here, I'm going to add an H and an OH. And this is an acid catalyzed reaction, so I'll stick that under the arrow. So now what I need to figure out is, how do I go from my reactant, my cyclohexanone, or cyclohexene, how do I go from cyclohexene to this diol that I need to do the acetal formation? And so that's a reaction that we learned back in fall quarter. Syn addition of 2 OH groups, and there was a bunch of different reagents that we could use to do this reaction. Potassium permanganate, as long as it is kept cold and dilute in a basic solution, will give us the Syn addition. Plus we also have a bunch of osmium reagents we could use as well. So that's one way to do this first problem. Moving on to the second problem, I'm going to start by just looking at what parts of the reactant, which carbons of the reactant are still present in the product. So I'm highlighting, that's what I'm bringing into the molecule, which means these are the parts that I need to add. So I need to make a carbon-carbon bond. I need to make this carbon-carbon bond right here. And since I am coming into this problem with a bromine already attached, this makes me just kind of want to do a Grignard reaction. That's what I'm gravitating towards. So I'm going to start by making my Grignard, magnesium in ether, and be really careful not to lose any carbons. Grignards react with carbonyl compounds. We need a 3-carbon carbonyl compound. That's how many carbons we're trying to add to this particular molecule. That is probably not going to be possible. I know that I that this carbon right here is the carbon that's going to be attacked by my Grignard. So I know that carbon has to be part of a carbonyl. I'm going to color code it blue so you can match it up with this guy right here. And this carbon needs to have, we know it needs to have a methyl group coming off of it. So there's the methyl group. And what we want is to have a double bond CH2, except no, that's not going to happen. That's a carbon with 5 bonds. So we're not going to be able to do that. It's not going to work. But we're going to be able to do something. So let's just do regular hydrogen out here. We'll start with that, and we'll see where this gets us. So here our Grignard is going to attack this carbonyl carbon. We're going to open up the carbon-oxygen double bond, and we're going to be really careful with our carbons here. I'm going to make this, here's our blue carbon. It's got a CH3 on it, and we have an O negative, so we haven't lost any carbons yet. And let's take a look at how we're doing in terms of coming up with the right number of carbons for our product. 1, 2, 3, 4, 1, 2, 3, 4. So we have a nice carbon chain. Second thing that we always do with the Grignard is just protonating using water or using H3O+. Protonate that R group. I gotta squeeze that in a little bit closer. We're just gonna write H+, and this is gonna give us an alcohol. So we're not done yet, because what we need to do is take this part of the molecule and turn it into a carbon-carbon double bond. We need to add another carbon to this molecule. Now I know, because we just learned the Wittig reaction, I know that if I use sodium dichromate, Na2Cr2O7 and sulfuric acid, I'm going to oxidize that alcohol to a carbonyl group. Carbonyl group, there we go. And then I can do a Wittig reaction, PPH3, with my desired, that one last carbon that I need to add up top, which is just a CH2. And that is one way, I'm sure not the only way, to make this molecule.